we go, and we're off. Okay, quadratic form is something like this. If don't write this down, I just want you to understand that they are very similar. If I have, in this problem, x to the fourth minus 13x squared plus 36 equals 0, you guys would like it a lot more if it looked like that, right? Well, x to the fourth minus 13x squared plus 36 also has quadratic form. We say it has quadratic form because the front exponent, 4, is twice the middle exponent, 2. And then there's a constant on the end. It has quadratic form. So like x to the sixth minus 13x to the third plus 36. That also has what we call quadratic form, meaning we can factor it. We can even use a complete the square method. We can use a quadratic formula. Now, I've reserved all the problems to be factoring problems. The first year, I made them do one with the quadratic formula. It does get a little bit messy. B would be the quadratic formula unless we put a plus there. Now it's factoring. So we'll make that change. We'll make them a little bit easier so we don't get too lost in the process. So we just treat these like we would a quadratic one. We'll try factor it. So instead of x point in front, though, what do you think I put there? X squared. Good. Now, what are the two numbers that multiply 36 but add a negative 13? Minus 9 and minus 4. Good job. It's okay. All answers are correct today. It's Friday. Everything goes, right? All right, do these factor? They sure do. From the beginning, you could tell that you should have how many solutions? 4. And x equals plus or minus 3. So you have plus or minus 2 and plus or minus 3. Paul, do you need set notes? Okay, you told me and I forgot to give it to you. So let me get those for you, okay? Actually, I got them right here. How's that? I wrote a little bit on them, but you could go ahead and just take them as your own. I don't need them at all. So you can flip open 1-5 and go from there. Yep. If you forget your notes, sometimes I have extra copies sitting around. Not all the time, but sometimes. All right, B. That also has quadratic form, and it does factor. Okay, what should go in the front? Good, 3x squared and x squared. Now, it's minus in the middle, and it's plus on the end. The only factors of 1 are 1 and 1 or negative 1 and negative 1, right? So you know it's going to be a minus 1, minus 1. But I should check to see if I still get negative 4x squared in the middle. If you check, do you get negative 4x squared? You do. So it looks like that's factored correctly. Does the right side factor? Yeah, this is the difference of two squares. Factors to x plus 1 and x minus 1. Yeah. Oh, good question. So if you look in the middle, I get a negative x squared. And if you look here, I get negative 3x squared. And that will make a negative 4x squared. So if you have a coefficient greater than 1 out front, you have to check the inside and the outside. Okay? Good question. So x squared minus 1 does factor. It factors to x plus 1, x minus 1. So you have solutions of positive and negative 1. But does 3x squared minus 1 factor? No, it doesn't. And so what we can do is we can treat it like a binomial that it is, and we can just solve for it by setting it equal to 0. Maybe you remember how to do that from Algebra 1. What are we going to do to both sides? Add the 1, and then I divide by 3. I get x squared is equal to 1/3. Square root both sides. Can you take square root of 1? Yep. Can you take square root of 3? Nope. So you get plus or minus 1 over the square root of 3. Can you leave the square root of 3 in the denominator? No. You can leave a variable as a square root, but not a number. So to get rid of a square root in the denominator, I multiply the top and bottom by the root of 3. Square root of 3. I get plus or minus the square root of 3 over 3. So there's my four solutions. Positive and negative 1, positive, negative, square root of 3 over 3. Does C have quadratic form? Yeah, 4/3 is twice 2/3. So it as well has quadratic form. Now, these are rational exponents. We don't know for sure how many solutions it's going to have. The numerator says 4, so there's a good chance there will be 4, but that's not necessarily the case. Yes. Then we give up. Then we would resort to, you're going to learn how to do that chapter 3. So you bring up a very good question. What if you have x to the 5th, okay, minus 2x plus 1, 2x squared plus 1 equals 0? Well, that's not quadratic form, is it? So the question is, how do we solve that? We can. It takes a little bit other methods, and we'll try that in chapter 3. Okay, good question. So what times what is x to the 4/3? X to the 2/3. X to the 2/3 times x to the 2/3 makes x to the 4/3 because we add the exponents. What two numbers multiply at -4 but add a -3? -4 and +1. Actually, x to the 2/3 minus 4 does factor, but we don't need to worry about factoring it. Let's just go about solving it like we did the other ones. X to the 2/3 minus 4 equals 0. So x to the 2/3 is equal to 4. In order to solve for x, the exponent of 2/3 needs to be an exponent of what? Instead of a 2/3, I want just a 1. I want x to the first, right? X to be equal to something. What would I do to make that 2/3 a 1? Raise it to the reciprocal, the 3/2. Because when you take a power to a power, you multiply. That's going to make that exponent 1 instead of 3/2. So I have 4 to the 3rd square root. Yeah, but be careful. Let's do it the other way. You could also do 4 square root to the 3rd. Let's try that first. What's the square root of 4? 2 or? Right. Then take 2 to the 3rd and you get 8. Take -2 to the 3rd and you get -8. Now, I'm not going to test you on that, okay? That's for a later discussion, a later chapter. If you could get the 8, good. I'll leave it alone. But technically, in this problem, both 8 and -8 work. So when you would take a square root before, you would have to list the positive and the negative. You're kind of doing the same thing there, so you got to be careful. Okay. All right, and then we also have x to the 2/3 is equal to -1 when you solve the other side. Yep, plus or minus 8 is fine. I'll use some space over here. We have x to the 2/3 plus 1 equals 0. So therefore, x to the 2/3 is equal to -1. Again, to get rid of the exponent of 2/3, I raise it to the power of 3/2. Just think about this. What's negative 1 to the third power? Negative 1. Square root I. Positive or negative I. Now again, I would not ask you to write both the positive and the negative I. Simply just understand that there's not a real solution to that portion. So, that's how you handle it. Are there any questions on that problem? Okay, and we finish off this last one before we go to the back side. Back side goes pretty quick. You should have some good time to ask some questions here. Move up and down. There we go. Okay, so I'm going to rewrite this instead of the square root of x. I'm going to rewrite it as x to the 1/2 minus 5x to the 1/4 plus 6 is equal to 0. It is 1/2 twice 1/4. Yes, so therefore it has quadratic form. Looks like this should factor. What multiplies to give you x to the 1/2? X to the 1/4 times x to the 1/4 makes x to the 1/2. -3, -2. I can take both of them and set them equal to 0. X to the 1/4 minus 3 equals 0, and x to the 1/4 minus 2 equals 0. So x to the 1/4 is 3, x to the 1/4 is 2. How do you get rid of the 1/4 power? Raise it to the 4th. Three to the 4th is 81. 2 to the 4th is 16. Those are your two solutions. You can plug them back in and check, make sure they work, and they do, in fact, work. Okay, let's flip it over. 4 more problems. Now, instead of having a solution, we're going to solve an equation for an indicated variable. So E equals mc squared. If I want to solve for C, how would you start that? What would you do first? Good, divide by m. So E over m is equal to c squared. Then, square root it. Square root of E over m is equal to c. If it's a variable, you don't have to write plus or minus. And if it's a variable, you can have a square root in the denominator, just not numbers. I know that seems weird, but you'll learn more about that as we go on, why that's true. We can leave square roots of variables in the denominator. R equals TMG over Q squared. Solve for M. What do you do first? Good. R times Q squared equals TMG. Now, divide by T and G. So M equals RQ squared over TG. Well, those are pretty straightforward, right? We can always make them more difficult. So we'll end with C and D. And for C and D, what we're going to do is we're going to solve for X. What makes it more difficult to solve for X in these scenarios than it was to solve for the other variables in the other ones? Yeah, there's two. You got X here and you got X there. So when X is located in more than one spot, that makes it difficult. Let's first just cross multiply to get everything on one line. If I multiply through by 3, I get 3rx minus 12 equal to 2px minus 2r. So now I've got everything kind of in a line there. Maybe I just cross multiplied. So here's the rule. Here's what you need to follow. So this is a problem that about half people get right on the test, about half people get it incorrect on the test. So I'm going to try to help you here. When you get to this spot, um, we want to solve for x. You start by putting the x's on the same side and the other stuff on the opposite side. So what do I want to move over to the left-hand side then? Yeah, the 2px I could subtract over there. And I could add the 12 to the other side. Everything on the left-hand side shares a common factor. What's the common factor? X. Factor it out. Now, how would you solve for x? Very good. Divide off the rest of the stuff. Very good. Kind of a nice trick, isn't it? You could take 2 out, but you would want to try to take 2 out of the bottom, to cancel it out. If you wanted to factor the top to leave it as 2 times 6 minus r, that'd be fine. But it's no better, no worse. So D, I'll just distribute my 4 so I can see what my terms are. And so when you get that type of problem on your test, what are you going to do? What are you going to do now? Put the x's on the same side. I'll move the 4x over to the left. And I'll put everything else over on the right. So I move the 5 over to the right. What's my next step? Factor out my x. Divide off your 3b to the third plus 4. You get 4y minus 5 over 3b to the third plus 4. So we've solved for our variable. Doesn't really look pretty, but it's very useful that way. Now it's a function I can use. Okay, so all I have for you is the problems that we started out with. I'd like you to try 3 of those that are quadratic form, so they should factor. And then 4 where you solve for the variable. That model almost identical to what we just did. And that's it. So that would be kind of your third part from section 1.5. I didn't write the other 2 on the board. I'm going to have to get that from somebody else. But that's it. On Monday, you have a full day to work, to ask questions. What I really encourage you to do is get caught up on homework tonight, or I'm sorry, probably not tonight. You probably want to do other things than homework tonight. Sunday after you watch the Vikings beat the Chicago Bears, sit down and do some pre-calc and make sure you see the questions that you have in front of you. So finish that up. So then Monday when you come, you can just start right into asking the questions that you have, the stuff that you're confused on. Then Monday night, you can go through the study guide and then come on Tuesday with questions you have on the study guide. And you'll be fully prepared for your test on Wednesday, and you'll get a bunch of A pluses, and you'll be my smartest class I've ever had. And I'll put Carissa's score right on the board for everyone to see. So, all right, we got post 15 minutes, ask some questions. So